So for today, we will continue with the topic, and in this case, we are going to discuss about earthwork operation. So the earthwork that we are going to discuss today is related to road and transportation. Okay, just before that, I think you have seen that, right? From my e-learn. I think you have seen that from my e-learn. So this will be your assignment, right? This is your assignment, which is due in week number 6. Week number 7, remember you are going to the site. So before you go to the site, you have completed the assignment. It is about there are 3 what you call description here. It is about providing a suitable road technology for rural accessibility. So in this case, the situation is you can see here the rural area need access road quickly. Rural area maybe near border, maybe somewhere near the hillside. Rural area need access road quickly. The proposed route is covered with weak ground. Maybe you can imagine that weak ground, fire, soft ground, not very nice place to go, but you need to build a road there. Weak ground, it could be pitch area, pitch, P-E-A-T, swamp and muddy area, like sawah, and that will prevent the use of heavy machine. You cannot bring heavy machine. So that's the situation. You cannot bring heavy machinery like big excavator, because that will, it just cannot go in because the soil is too soft. So what are you going to do? The situation will prevent the use of heavy machine and vehicle. Even a big lorry to transport, for example, soil and crusher run, aggregate and so on, could be stuck along the way. So in the current condition, only 1 ton, only 1 ton pickup truck or 3-ton lorry are possible to go in. 3-ton lorry is a small lorry lah. 3-ton lorry, and all 1-ton pickup truck can go in. So that is the scenario of the site. So now you can imagine that situation. So number 2, so you are requested to provide a recommendation on what material, right? What material and procedure to successfully build the roadway. This is what I call access road. Right? So you are requested to provide recommendation on what material and procedure to successfully build the roadway. Number 3, of course, before you can do that, you need to do some study, right? You need to do some study. So number 3 is basically the how you will do that. Carry out literature study, from online sources, and or discussion with the relevant professional. Those of you, especially that has been to internship, you may have some networking now, so you can discuss with the people who are involved in construction about what would be the possible solution. Or even some of you who have not been to internship, but that is okay. You can talk to your colleague, your friend that has been to internship, or your seniors, or even your whoever has been in contact with you, especially people who are in the construction world, and even better if they are in road construction, who can give you some idea, right? So, but mostly, at least you will need to do the literature study from online sources, right? and then prepare 10 pages, including graphic. But don't put one graphic in one page. So put a reasonable what they call it size of graphic if you need to illustrate anything in the what they call proposal. So this is what we call assignment that you need to submit in week number 6. We have a situation, what you need to do, number 2, and what is the approach suggested. Of course, you can have different approach, but I would say within this 4 weeks, 1 month time, probably the online sources will be at least can provide you the relevant information that you need to prepare your proposal. Right? Based on the previous case study, for example, then you should be able to do that. Okay, that is the assignment for this subject. Next, let us continue with today's class. Okay, last week I already mentioned this. Earthwork is a major factor in terms of cost of most projects, especially road projects. One of the major objectives of road, how your road go left and right, for example, whether you want to go this way or you want to go straight or you want to go to the right, that is to minimize the amount of car and field. So that is actually the why we need to do the evaluation. Okay, in this case, for example, we have decided to use this green alignment as our proposed road. So in order for us to achieve that alignment, you can see here, definitely we need to do some, in this case, we need to cut the hill. There are also situations when you need to fill, especially in your case just now, where you have a very big ground. You need to build an environment to ensure that you have a strong base, and also to achieve what we call a platform that will not be underwater when they are completed. So that's the situation. So if you are going to be involved in road construction, this is definitely one of the plans that you will encounter, that you will see in the contract document, contract drawings, and in the contractor's office, in the consultant office, in the client office. This is called road horizontal alignment, road horizontal alignment. And the one at the bottom here is road, what do you call it, vertical alignment, right? Vertical. So you have horizontal alignment and vertical alignment. If we are going to construct the building, we know the building will be in certain shape, right? But road, it will go, it will go linearly from one point to another point, but most of the time it's not going to be straight like a building. You have a straight line. You will go to the left, to the right, up and down. So that is why we have what we call horizontal alignment to show where to turn left and right, and up and vertical alignment that shows you the ups and down of the road. So for us to achieve that, left and right, up and down, definitely there will be soil or earthwork involved. So let us look at this plan. What does this whole thing mean? Okay, usually in a construction plan, or even during if you need to design the layout, you will have this plan view, or top view, you can say top view of the earth. So you can see this is why you have what we call contour line. You You see contour line and other line here that shows where the road is. For example, in this case, the road is straight over here, right? At the bottom here is actually a section plan or elevation. We're talking about buildings elevation. You cut section, right? But the section is longitudinal, meaning if the road is from here to there, so the section is cut this way. They ask plan that cut this way. That is called cross section, right? This is long section. So this is long section. Long section will show you the vertical line. You can see here. Let us look at the horizontal alignment first. But this horizontal alignment is straight. It doesn't go left and right. So this is the road actually. This is actually the North-South Highway plus highway near Bukit Lanjan, Jalan Buta. You can see indication of what they call cut slope here. Cut and cut, right? And over here is fill because the arrow is going away from the road. This is the road, right? I put blue and red color so that you will give a better depiction of the situation. Remember, this is a long section, the cut section of long way. This is the proposed road. This one here. It looks like this road is climbing. It's climbing the hill, right? And this is the plan view. The plan view, we don't see whether it's climbing or not because the plan view is supposed to tell us whether it turns right or left. So in this case, it just goes. So you see, the original ground is this one here, this one, the dotted line here, the dashed line, right? So this area here, the approaching point here in blue area is need to be filled, meaning you need soil to fill this area to reach this level. Original ground, you need to fill up until this level, so you get that platform. Over here is a hill. You need to remove this. You need to remove so that you can have, it's like, this is the hill, so you need to have this road, you need to cut away. So you will cut, not the whole hill, but only your what do you call it, your center line, based on the center line of your road. But the thing is, definitely you need to, from the center line up the hill, the box smaller. Okay? But to the left or the right, the hill will still remain. So this is the plan that will tell you basically how much cut and how much fill, how much earth will be removed, how much earth will be required to use as fill here. So this is directly related to earthwork, definitely. So we need to know how much of cut and how much of fill will be involved in this work for us to be able to plan, for us to be able to estimate, for us to be able to what do you call it, be ready with the proper equipment that is required for this work. Definitely in some soil it's harder than the other. So if it's rock, then you may need plastic, you may need a heavy machine to break the rock. If it's soft soil like here or over here, maybe it's in soft soil. So when you fill, it may settle into the ground. So you need more soil to fill up. So that kind of thing for us to plan. So that is the basic, the most fundamental plan in road construction. That is just to show you the alignment, the horizontal alignment, right? The road can be like this, you can go to the left and right. That is horizontal alignment. You will find that information from the plan just now, from the plan view. The other one is, of course, the up and down. But the thing is, when you construct road, it can go simultaneously, the left and right, and up and down at the same time, right? So that makes things more, not to say complicated, it makes things more, that kind of road is more interesting rather than, straight road, gantung bawah, things like that. Ataupun jalan yang rata, tak naik tak turun. Straight down, straight, flat. Right. So if you have a road like this, that will be more interesting to drive. For me lah, I'm not sure for you. Right. Okay, this is another drawing that you will see in the road construction drawing. This is called cross-section, right? Cross-section, just now I mentioned it, you have a roadway here, you have a long section to show you the vertical alignment, and also to show you the plan view of the horizontal alignment. By the way, this horizontal alignment calculation and vertical alignment calculation, you will be exposed to this by Dr. Aliza later on what is the calculation. I think that will be where the calculation will come in. And the horizontal alignment, vertical alignment, usually there will be questions in the exam or at least test or it is quiz. Because that is part of the calculation from this subject. But I'm not going to talk about that because that will be explained later by Dr. Liza. So this is another kind of drawing which is called cross-section. Cross-section is, this is the road, you cut at every certain interval. For highway like this, the interval is 25 meters, 25 meter. We cut, kat ini kita tengok. For example, this is the original ground. That is the original ground. Alright, and then you need to fill. Or this is another original ground, you need to cut. Cut is red. So usually in the road drawings, cut means red means cut. Red means cut and blue means fill. Or embankment. So this what do you call it, dimension and configuration will help us determine, quantify the amount of earthwork, right? The amount of earthwork to be cut or to be imported to site. Like I said, this cross-section drawing will be provided or will need to be provided at a certain interval. For highway construction, it is 25. For local road like Perumahan, Perumahan, it's about 10 meters, every 10 meters. Maybe from there to here. One section here, one section over there, another section, and so on. Cross-section. So you need, when you need to provide this cross-section in order for the builders especially to find out what is the amount of soil to be cut in this case, or what amount of soil to be imported to achieve this level. Right? So this is another drawing, another typical kind of drawing that is not typical, required to do. Otherwise you will not be able to properly construct the road. This is another example of vertical alignment, meaning the long section. In this case, the distance is 10 meters, so this is housing project, right? You can see the green one. The green line here is the existing ground. The more straight line here is actually the proposed road. So fill over here, cut up there. So the red one is actually the road level. So this calculation you will learn from Dr. Aliza, right? But the detail in the drawing is most of the time this is what you need to know in the drawing for if you are going to design or if you are going to construct. You need what is the existing level. what is the chainage? Chainage means the distance from the starting point, 0, 10, 20, 50, and until how many kilometer. And the design level. What is the finish level? So design level. So these are the three most important information for this kind of drawing. Of course, other thing is about the curve. You know, the vertical curve, we call that. You will learn that. And also the slope percentage, because you need to mark on the ground for the machinery to supply or to cut the soil to the level that is required. Those are the details that you will learn from the design. Okay. The thing about earthwork is it doesn't matter if it's a road or building. We have got what we call a regulation and law that govern earthwork operation. Anyway, in Malaysia, in different states, in international situation. But the thing about earthwork or soil is always what do you call it? Need to be adapted to the local regulation. For example, in Penang, the earthwork bylaw, for example, stated that if you are going to do a piling, you need to construct a trench if the piling is expected to give very high vibration and cause nearby building to what do you call it, to affect nearby building. How do you consider, or how do you determine whether there is a need for a trench or not? So that will be spelled out in the bylaw. The basic bylaw is provided by the federal government, but when it comes to state to district, it will depend on the actual situation within the district. Another thing about soil is that you cannot be transporting soil here and there. Soil is like oil, you know. Is the hak milik kerajaan. Soil. You cannot. If you need to transport the soil somewhere else, you need to pay what they call royalty to the district. So that's why, also by law, it may be what they call it a little, maybe organized or adjusted according to the local requirement. If you go to Cameron Highland, for example, they have issues of what they call issues of erosion and so on. Their earthwork bylaw may be what they call it maybe modified to suit that. So you need to read the bylaw properly before you do any earthwork in any locality. But the thing about road is, it is usually will not be in one place. You start from Penang and in Johor Bahru, for example, you know, North South Highway. So you will be passing through many local authorities. So you need to know each authority that you pass through regarding the bylaw in each of the district. Right? This is to show that one example in the bylaw where let's say this is your highway on the left, right? Your road. This is model. This land belongs to someone else. This is your road reserve. So the first one is okay if you need to cut the soil like that. You know, you need to cut, and then your slope go up and end at border. You still leave some slope here. For the second one, you'll be in trouble. You get a legal issue if you still have your road within your side, but your slope go into other people's land. Then that's not allowed. That is one example of how this bylaw spell out what would be the guideline in works related to soil and earth excavation or field. Right? So it's a good idea for us in this built environment field to get to know what is a road bylaw. Read whole thing. Definitely you will be referring to it later because we cannot run away from soil whenever we do a reliable project. Definitely we will deal with soil. Unless you have what you call, doing construction in space, like the space station. That's no soil. So that's different. The same thing with the cart, field, just now it was cart, right? This is field. So if this is the boundary, this is your side, you cannot be spreading your soil to other people's land. You need to stop here. Right? Just stop. Yeah, look at this road. I'm sure you, I don't know, some of you maybe have passed through this place many times. This road is an island, right? And it may look different now than when the picture was taken long time ago. So you see, to get this road, this platform for road, you need to cut. But the thing is, the hill is so steep nearby the road. You need to cut and stabilize the slope so far away up there to create this platform. Of course, you can do this, but because money, so that depends. You decide. You want to have a wall to retain the soil, or you want to have a stable slope. Which one is cheaper? That one you need to advise your company, your organization. You can do the calculation, right? Whether it's cheaper to buy land nearby to create the slope, or it's cheaper to construct wall other than buying the land, whatever. So that is economic analysis that probably you have learned in some of your subject. The thing about slope is it must be designed and cut or filled according to certain specification. Otherwise, this will happen. We will fail. So follow the design and drawing. Don't try to cut. For example, today you go and cut this place. You cut at this slope. Oh, belum betul. You cuba bagi steep sikit. Tak betul lagi. Lagi you buat tegak. Tak betul tegak, okey lah. Dia kata. But it will fail later. Especially cut slope. Cut slope, it will not fail immediately. It will fail in time, later. Slope that you cut. You can cut this slope here vertically. It will not drop today, but it will later. That is the behavior of cut slope. It is the opposite of embankment. When you fill soil, you see when you fill the soil will spread, right? It will spread. The fill slope will fail immediately. You will not wait for time. So if your road is going to pass through a pendang, for example, or sea side, and you go there and start loading the embankment and create the level, it will fail immediately if it's going to fail. If it's going to fail, it will fail immediately. Immediately means immediately or 1 or 2 days. It will not wait. Macam cut slope, it can take 6 years, 5, 6 years, 10 years to fail. So that's the behavior of soil slope. Okay. So if you are going to construct a house, your house for example, you buy a hill and then you need to cut. So you must be careful because it will fail later, not immediately. You're not sure. But of course, if you think it's going to fail, if based on your calculation it's going to fail, so you need to do something probably like this. You need to reinforce the slope. This is called shotcrete. Of course, it may need money, but it's better than those slope fall onto you later. Right? Or another economic consideration. You want to have a wall, retaining wall like this, or you want to have a slope coming down here, right? So if you have a slope, so you only have road this wide. But if you have a wall, you can have a wider road. So that kind of thing. You need to decide what would be the best for your, based on what you need. Right? Of course, there are many types of water earth retention system. This is one of them. You need a space for road here. You cannot afford to have a slope because with that there will be no road, but you need a road. So you need to have a mega slope like this, a mega wall like this, for you to be able to provide this building up there. Otherwise, there will be no road because there's no space for it. So that is the need to create platform. You need to create space for road. You need to create suitable elevation of road. Will require what we call a road operation. So we'll go into how. So once we have, if you are planning a road, once we have the preliminary route of horizontal and vertical, which is left and right, up and down. Once the preliminary design of horizontal and vertical alignment is complete, the cross-section plan and every changes, the cross-section plan, can be prepared and a whole quantity can be calculated. Then we will be able to know what will be the amount of work cut and fill once we have got the preliminary design. Basically, we know we have finalized which way to go. Instead of going this way, I'm going this way, up, down, that way. So they will be able to calculate based on chainage. So in most road construction drawing, you will be looking at this CH. CH is chainage. Chainage is distance. Jarak. Actually, chain is actually a unit. You know, CHAIN, unit. Long time ago, before you were born. In the year 70s, in the 1970s, we still use chain. The year of your parents. Not even your age, your parents will still be anak-anak in primary school. That time, chain, or we call it English name. Chain, feet, Ella, what is Ella? And those things, mile. Those are distance unit that we use. But because of this, what I call it, the mechanic of calculation or the scientific calculation of mathematical expression it has been established a long time ago by the British, by the American in English unit. So that's why until today we still use chain. By right, it should be 40 chain, 20 chain, but actually now it's 40 meter, right? Walaupun CH every meter. Chainage 40, meaning chainage 40 meter, not chainage 40 chain. Right? Unless you are working in USA, they will still be using this chain in some of the projects. But probably now they have also converted to what they call SI unit, which is in meter. So that's what this is called chainage. Jarak, distance. In this case, you have chainage 20, which is here, 40, next one, 60, another distance. So 20 and 40. So how do we do the calculation? We compare this cross-section area and this cross-section area, then we will be able to calculate the volume. of the earthwork. So that is the basis of volume calculation for road. We call that we call that I will let you know later. This calculation is for excavation or cut and also embankment or fill. Excavation is the amount of material that need to be removed so that you can create your road platform. You need to remove to create your platform. Embankment is the amount of material that need to be bring to the side, or in this case to be added to the grade. This grade you not this level, so you need to top up until you get this level. So that's embankment. So embankment, excavation. Excavation now you have here, you remove it to get this level. Embankment, existing level, you want the new level here, you need to top up, so that is embankment. So to do that, we need to calculate what is the amount need to be top up or what is the amount to be removed. So for linear project like road or drainage or sewerage trench or anything linear project, well, usually we will be using this method, average end area method, or sometimes called double end area method, to do the earthwork calculation. So to estimate the quantity. So, what is the principle or concept of average end area method? Very simple. Maybe you know already. Remember just now, I have one chain here, I mean distance from here, 20 for example. The other one is 40, which is 20 meters from here. So the cross section of where I'm sitting is going to be cut like that. That is the cross section. This is the road. This is the existing ground, right? So that's the original ground, right? So that's the original ground. This line here indicating the cut, the removal of the soil for you to create this road. So you want to remove that. So in order for us to remove that, in order for us to calculate what is the amount of soil to be removed, we need to calculate the cross-section area. What is the area that is going to be removed at this side, and what is the area to be removed from that side? Maybe different. Maybe the road is going up here or down here, so the section over there and over here is different. So what we do, the concept is, average area method is to get the cross-section area to be removed here, cross-section area to be removed over there, you plus the two, combine the two, divided by 2, you get the average. So that's right, average. So once you get the average, you multiply by the distance. In this case, challenge 20, challenge 40, it means 20 meter. 20 minus 20, 20 meter. So 20 meter multiplied by the area in meter square, meter multiplied by meter square, you get meter cube. So that's the volume. So that's how we come up with the volume of soil need to be removed from here to there. Same thing with embankment. To calculate the area of the embankment section over here and over there, and you will multiply by the distance. Okay, now you may be saying, what if over here is cut, over there is filled? And over there is filled. That will be, later on I'll show you the form that we use. Because the fill is, you can consider fill negative or cut negative, but you need to be consistent with the sign. So it will for example, you have cut 20 meters square, fill 10 meters square. So 20 minus 10, tinggal lagi 10. But still you multiply by the distance, that means you have 10 by the distance amount of fill is required. A cut is required. So it will need each other, right? But most of the time you'll be dealing with the same cut or the same fill. That's only at the interface of somewhere that you will transition from cut to fill that you need to do that.